tissue. So earlier we have studied that ground tissue is non-vascular tissue, right? So what happens in vascular tissue? So these are the cells that specialize in transportation of the water and food. So where does transportation of water occur in plants and where does transportation of food occur in plants? So in plants, the tissue that is doing the transportation of water is xylem, whereas phloem helps in distribution of food to all parts of the plants. So what does the xylem do? It helps in transportation of water. Okay, so xylem helps in transportation of water. Okay, and phloem helps in transportation of food. Now let us study about both of them in detail. So xylem, how is the water transported? So water is transported from the roots to all parts of the plant. So how does xylem act as? It transports water in this direction. Okay, so how does xylem transport water? It transports from root. It transports from root to rest of the plants. Okay, and when these xylem cells die, they leave a hollow space. Okay, which is like pitted. So here the cells are dead and these cells help in water transfer. Okay, so how does the xylem help in transportation of water? So what does xylem do is it helps in transportation of the water from the root to all parts of the plant. Okay, and the direction is always in the upward way. So the water is always transported from the roots to the other parts of the plant. And these xylem cells, they die. Once they are dead, they have this pitted appearance. So what happens there is, through those small pits like structure, there is water transportation happening. Now coming to phloem. Phloem, what happens is, there is transportation of food, but the direction is opposite like of the xylem. So the food transportation occurs from other parts of the plants to the roots. So it is downward direction. So the transportation of food over here takes place in this direction. Okay, and the phloem cells are alive and they are porous, which helps in food transfer. So now that we have studied about xylem and phloem, so let us notice the differences. So xylem is transporting water from the roots to other parts of the plants, whereas phloem is transferring the food from upward direction to downward direction. Am I right? No. Xylem helps in transfer of water from roots to other plants and phloem helps in transportation of food from other plants to the roots. Okay, and the cells in the xylem die, and once they are dead, they form like a hollow pitted structure where there is transfer of water. Whereas in the phloem, the cells are alive, but they have pores through which there is transfer of food. Okay, and monocots and dicotyledons are, I'm going to talk about it in detail in the next class, but for now remember that monocots have one embryo and dicots have two embryos in them. Okay, so let us talk about in like a overview, like a flow chart of what did you guys really understand by the plant tissues. Okay, so plant tissues are mainly classified into meristematic tissues, dermal tissues, ground tissues, and vascular tissue. Okay, In the meristematic tissues, we have studied that they are of three types. okay, that is apical meristems, which are present at the stem or at the roots. Okay, so suppose think this is an apical meristem. So here when you cut this portion, there is a new part of the plant, that is a new leaf or a new flower would be growing. That is apical meristem. Whereas intercalary meristem means, I'll give you a very small and easy example. You have seen goats grazing in the field, right? So when the goat is going to eat a portion of the plant, the meristem that helps in growing in between those branches, that is intercalary meristem, okay. And lateral meristem helps in growth of the plant. Like a small baby mango plant would be of this size, but there is growth in the diameter that is happening because of lateral meristem. So we have understood now very clearly about apical meristem, lateral meristem and intercalary meristems. Now coming to the dermal tissues, what did we study in the dermal tissue? The outermost layering epidermis is present, which gives protection, and it gives the leaves waxy cuticle. This cuticle is very important because it plays a major role in protection of the plant, like it's a plant's own defense mechanism, okay. And it has root hairs that help in absorption of water. Okay, so when there are more root hairs in the roots, it helps in easy absorption of water. Now coming to the ground tissue cells, they help in storage, support and the process of photosynthesis. That is the mechanism where the plants can make their own food in presence of sunlight, water, chlorophyll and carbon dioxide, and the end products are glucose and oxygen. Coming to the vascular tissue, they are of two types: xylem that helps in water transport, that occurs in upward direction, that is from roots to other parts of the plants, whereas phloem helps in food transportation. Okay, now where is the transportation occurring? It is occurring from parts of the plant to roots. So these are the four important parts of a plant tissue. So we are clear on the meristematic tissue. They help in lengthening of the plant and increasing the diameter of the plant. That is the major function of it. Whereas dermal tissue, it has a thick covering, like how the glasses that we order, we place them in a thermocol, or whenever there is a packaging or shipping done of such kind of a material, we get them in like a boxes, because that box gives protection to the glasses. Similar way, epidermis is one of that kind, and it gives the dermal tissue present in the leaves, give it a waxy cuticle that is like a plant's own defense mechanism against predators, insects or any diseases. And then the dermal tissues are also present in the roots, where there are small tiny root hairs which helps in more absorption of water. And ground tissues are the one, they are non-vascularized. So if someone asks you which one is the vascularized tissue and which one is the non-vascularized tissue, example is xylem and ground tissue, always remember that ground tissue is non-vascularized tissue, okay, whereas xylem and phloem are vascularized tissue. So ground tissues help in storage, support and the process of photosynthesis. And vascular tissues, they are comprised of two types. Xylem helps in water production and phloem helps in food transportation. Xylem helps in water transportation, not production. So xylem helps in transportation of the water from roots to all parts of the plants, and phloem helps in transportation of food from all parts of the plants to the roots. So these are the different types of plant tissues. So I will be talking about each and every plant tissue in detail in the next class. Thank you for watching and stay tuned to Classroom TV. Thank you.
Hello students of 9th class. until now we have studied our chapter Our Earth. So we have come to our final session of this chapter. After this chapter, you please try to revise the concepts, and we will also go through the important keywords of this chapter, right, or whatever we have studied until now, all the important terminologies we came across in this chapter we will see. Okay, hope you are all doing fine. This will be our last session of this chapter. Try to revise and try to also answer all the questions behind the last page of this chapter. Okay, so in case of any doubts, you can please drop us a mail, or you can also write to us. You can refer our website classroomtv.in, and in case you have any doubts, you can also call us. Okay, so please keep seeing, and this will be the session number 5 or lecture 5, where we are discussing our Earth, all the important key terms, whatever we came across in this chapter. Try to just recollect what we did until now. Okay, so we started our chapter with a small tiny dot. Do you remember this small tiny dot? What is this dot? This dot is our Earth. Then who was the person who asked for the satellite images? That means images taken from the satellite Voyager 1 and Voyager 2, launched by American NASA agency, okay, that is Space Agency of America, that launched 2 satellites, Voyager 1 and Voyager 2 in 1977. And Carl Sagan was the American astronomer, astrophysicist and cosmologist who tried to get photographs and requested the NASA to take pictures of Earth from those satellites. So finally we have got a dot like picture of Earth, that is our Earth, what we studied until now. So whatever we studied, we have studied the evolution of universe and the evolution of Earth, different forms of theories like heliocentric, geocentric theory, and we have seen the internal structure of Earth. We have also seen the longitudes, latitudes and all the time zones, and we have also seen Greenwich Meridian and International Meridian, International Dateline also, and we will see once again all these concepts in a brief nutshell, and then we will end up our session for today. Okay, see here, so this is lecture number 5, Our Earth. This is class 9, as you know, state syllabus. Okay, see here, see, as I told you, we have started our discussion with Carl Sagan. Okay, so Carl Sagan was an American astronomer who was basically related to what? Related to American Space Agency, and he requested Voyager 1 and Voyager 2. Okay, so whenever you encounter a question about him, definitely you will also see other aspects like satellites of America, that is Voyager 1, Voyager 2 spacecraft, and from these 2 spacecrafts we have these satellites taking the pictures of Earth. Okay, so Carl Sagan was our initial man with whom we started our discussion. Okay, number 1. Number 2, we discussed in detail about Big Bang theory, right? So what is Big Bang theory? See, Big Bang theory, we talked about how galaxies and universe evolved. Okay, so initially everything was a compact structure, entire universe, there was no planet, there was no galaxies, nothing, entire structure was a compact whole, and this compact whole over a period of time expanded, and suddenly was subjected to a huge explosion. And because of this huge explosion, we saw all these galaxies getting scattered like anything. Okay, when these galaxies scattered like anything, our galaxy also called as Milky Way galaxy. So our galaxy also was thrown to one side, and we are studying that thrown away Milky Way galaxy, in which our solar system is there. So we can say that in a nutshell, around 3.7 billion years ago, all this important phenomenon of evolution of universe happened. Okay, that you have to remember. Okay, what is that? 3.7 billion years ago. Okay, so whatever we have discussed until now, I am just trying to brush it up about 3.7 billion years ago. So from 3.7 billion years ago to 4.5 billion years ago, 4.5 billion years ago. So how do you differentiate? So 3.7 billion years ago was the time when actually universe came into existence, and 4.5 billion years ago we'll talk about our earth, okay, our earth formation finally taking place, our earth formation, okay. So here how much of gap? 3.7 billion years ago and 4.5 billion years ago, okay. So when you're talking about 4.5 billion years ago and our earth, we will also talk about the continental drift theory, okay. So don't worry, we will see all these concepts. So this is all Big Bang theory. In this Big Bang theory where universe exploded, finally galaxies got scattered, and one such galaxy is our Milky Way galaxy, where our solar system is there, and in this solar system we will see what? We will see our earth in course of time, okay. That is what heliocentric theory and geocentric theory. See, initially when universe was formed, okay, there was no life, as you know. After by the time 4.5 billion years ago also there was no life, okay. That means from 3.7 billion years ago and 4.5 billion years ago, here also there was no life. There was no life means what? There was no life means there was no conducive atmosphere, that means there was no oxygen, okay. So without oxygen how life can exist? So there was no oxygen, but everything was there, everything except oxygen was there on the earth. That means most of the other gases like methane, okay, ammonia, okay, carbon dioxide, water vapor, okay, many such gases, nitrogen, helium, many such gases was there except oxygen, okay. That was the reason in our session we called this period as this atmosphere, initial atmosphere was also called as primordial atmosphere. Do you remember? Primordial atmosphere. This might not be there in your textbook, but very important, you might even come across in your higher sessions or any competitive examination. Primordial atmosphere are also called as reducing atmosphere, okay. Reducing atmosphere means there is no oxygen, that is the reason it is called as reducing atmosphere. That was the story. So from here we can say that around 220 million years ago, this was the time of Cretaceous period in geological time scale. If you see, this is the Cretaceous period or Jurassic period, where lot of huge reptiles which wandered across the earth, which enjoyed their heaven on earth, which is called as Jurassic period in the geological time scale. During this period, earth started slowly unwinding, slowly moving into different parts, slowly unwinding, slowly breaking up into different parts. So this is called as continental drift theory, okay. This is what, okay. See, this is called as continental drift, this is called as continental drift, okay. So this is called as continental drift. So you have to understand that for 13.7 billion years ago, 4.5 billion years ago and 220 million years ago. See here, see we have to understand that here what we are talking is Big Bang theory, okay. Big Bang theory. See, everything is there in this diagram. Big Bang theory, that 13.7 billion years ago and 4.5 billion years ago, evolution of our earth and atmosphere reducing and primordial atmosphere and all such important gases, and from there we are going to continental drift theory of Wagner, okay. Continental drift theory of Wagner, okay. Now you understood how we evolved from 13.7 billion years ago to 220 million years ago, that is billion and this is million, okay. So finally during this point of time during this point of time when earth was slowly evolving, in the ancient days there was a misconception that earth is the center, and all such heavenly bodies and all such sun and all other planets were revolving around the earth. This is called as geocentric theory. Okay, this was called as geocentric theory. This is also we have discussed. Okay, geocentric. Okay, but over a period of time this theory was completely disproved, and people came up with Copernicus. He came up with a different theory called as heliocentric theory. This is called as geocentric and heliocentric theory. Helios means sun. Okay, so according to him that earth is not the center of the solar system. According to him, sun is the center of the solar system and all other planets revolve across the sun. This is called as heliocentric theory. Okay, this is all about heliocentric and geocentric theory. So Carl Sagan, Big Bang theory talks about what? Talks about evolution of universe, entire universe, and talks about splitting and scattering of galaxies, and next talks about heliocentric and geocentric theory, talks about the positioning of planets and earth and sun in different orbits. So which of them is correct? Heliocentric theory is the accepted phenomenon. Geocentric theory was the oldest phenomenon where it was disproved in course of time by the astro scientists. Okay, that is what. So next we have to discuss perihelion and aphelion. See, when earth is revolving across the sun, okay, so earth is rotating across the sun, this is what, okay, sun is there, earth is rotating. Okay, when it is happening, what is there? See, this is sun and this is earth. When earth is rotating across the sun, definitely whenever earth is closer to sun, that is called as perihelion, and whenever it is away from the sun, that is called as aphelion. This is what we have discussed in relation to the position of the earth when it is rotating across the sun. Okay, that is what. Okay, revolving across the sun. Okay, next, formation of the earth. We have discussed about the formation of the earth in our session also. Okay, formation of the earth, that is about what? That is about okay, what we have discussed, that is about 4.5 billion years ago. So here all such important concepts we will encounter. Okay, what is that? Continental drift theory. In this theory only you will find two such important keywords in your textbook, that is Laurasia and Gondwana. Okay, this is all what we have discussed, right? Laurasia and Gondwana. So what is that? So we have discussed all these concepts, Laurasia and Gondwana. How we will talk about this? See, when initially this you will understand clearly, try to understand. Laurasia and Gondwana, everything was in a compact structure. Initially when earth was evolving, everything was in a compact structure called as Pangea. This we know already. Everything was in a compact structure called Pangea, and this Pangea has got two important structures, two important divisions, structures which are divided into northern and southern region. One is called as Angara land. One is called as Angara land, and another is called as Gondwana land. Okay, another is called as Gondwana land. Okay, Angara land and Gondwana land. Angara land is also called as Laurasia. Okay, that is what we have discussed, right? Laurasia. So this is the structure. When you have to just try to recollect, when it is happening, this entire unwinding or opening up of the earth's surface is happening, and that means dividing of the earth's surface into different continents is happening. When it is happening around 220 million years ago. Around 220 million years ago, when dinosaurs were dancing on the earth, they were enjoying like anything. At the same time, earth was slowly trying to unwind and going and establishing into a separate continents. Okay, so what we are seeing now is a fully established form of the earth, and even now we will see every year there is movement of the plates across each other, movement of the plates towards each other. Every year you will see, you will not see, but every year we can say that around a few centimeters or few meters of the continents or land masses are moving towards each other. Okay, that is still, that is a continuous process, but for now we can say that Pangea or 220 million years ago, this was the structure what we have discussed in our session. And now if I ask you, where is India? Question is there in your textbook. India belongs to which part of Pangea? Okay, India belongs to Gondwana land. India belongs to Gondwana land. In this Gondwana land there is a plate called as Indo-Australian plate. There is a plate called as Indo-Australian plate. In this Indo-Australian plate, what is there? India is there. Okay, India is there. Okay, our location, our plate, that means our country belongs to Indo-Australian plate. Okay, so in this Angara land or Laurasia, which of the important plates which was responsible for a collision with Indo-Australian plate? That is Eurasia. That is Eurasia. That is Eurasia. That means, for example, this is entire Angara land. This part is called as Eurasia. Okay, this is Eurasia. For example, this is entire Gondwana land, and this part, see here. Can you see here? This part is called as Indo-Australian plate. So this part is going and hitting this part. Okay, I'll draw for your saying in a bigger diagram. So for example, this is Laurasia. This is in Eurasian plate. This is Gondwana. This is Gondwana, and this is the Indo-Australian plate. This is going and hitting this Indo-Australian plate. Okay, this is what we discussed when we were discussing about the formation of Himalayas. That you will discuss, that you will see in the higher classes. In 10th class you will see the geological history of formation of Himalayas. Okay, see here. See, what is that we have discussed? Pangea 220 million years ago, Angara land and Gondwana land. And what else are there here? Between Angara land and Gondwana land, they are not tightly packed. Sea is there between them. Okay, what is that sea? What is that sea we have discussed? That is the Tethys Sea. That is the Tethys Sea. Okay, Tethys Sea. That is what? Between Angara land and Gondwana land. And what is the ocean which is encircling entirely? What is the ocean? This ocean is called as Panthalassa. Okay, what is that? This ocean was called as Panthalassa. So what are the four important things which were there when Earth was slowly unwinding? Four important things. One is Laurasia or Angara land. Next is Gondwana, and next is what? Next is Tethys Sea. Okay, and Panthalassa, LGTP. Okay, so these are the four important points you have to remember when you are talking about Laurasia and Gondwana, and also continental drift theory of Wagner. Okay, this is what. Okay, now you understood everything. Now we will go to our next concept. Okay, what is that next concept? Internal structure. Okay, this is bit complicated. Okay, we talked about internal structure of Earth also. What is the composition of the different layers of the Earth, crust, mantle and core, and what are the main elements present in the core region. Everything we have discussed. What is the density and what is the depth of each and every layer of the Earth's surface. Everything we have discussed. If you we can also see that once again. Okay, here, see here, this is what we have discussed. You might have remembered everything. So crust is all 100 kilometers deep from the surface of the Earth. Okay, for example you take here. So this is the crust region. Crust is 100 kilometers deep. From here, 100 kilometers deep, only 1% of the volume of the Earth, entire crust region. And next is mantle. Okay, for example, this is mantle. Mantle, 16% of the volume of the Earth. It exists at a depth of 100 kilometers to 2900. From here to 2900 kilometers, 100 to 2900 kilometers. Okay, so this is crust, and this is mantle. Okay, this is mantle. Okay, the upper part of the mantle is a pliable layer over which the crust floats. Okay, see, this is the mantle and over which the crust flows. Okay, over which the crust flows. Over which the crust floats. This consists mainly of chemicals called as silicates. So see here, and this is called as core region. Core region, this is the uppermost and this is the innermost, and this is mantle. What will you find here? You will find what? You will find silicates. Okay, silicates. And if you talk about volcanoes also, from where will you find the emergence of volcanoes? You will see volcanoes erupting from where? Erupting from the region of mantle only. From the region of mantle only, volcanoes coming out. Okay, right? Volcanoes. And because of this volcanoes, what kind of rocks we are seeing? We are seeing igneous rocks, right? We are seeing igneous. Okay, igneous rocks. Igneous rocks. Once the molten lava cools down, you will find the igneous rocks being deposited over the surface of the earth, that is crust. This is a cyclical process. Okay, see here, this is mantle, and so mantle is how much percentage of the volume of the earth? That is 16%. Crust is just 1% of the entire surface of the earth, and mantle is 16% of the volume of the earth. 16% of volume of the earth is all mantle. Okay, so where we are staying? We are on the crust region. Okay, we are on the crust. This is the topmost layer of the earth. Okay. So the upper part of the mantle is a pliable. Okay, that is over. And next, core, 83% of the volume of the earth, from 2,900 kilometers to 6,300 kilometers, composed of dense heavy substances like iron and nickel. Okay, 2,900 to 6,300. Okay, see here, from 2,900 to 6,300 kilometers deep inside you will see the core area. Okay, and this is the outer core, and this is the inner core region. So what will you find in outer core or inner core? Iron and nickel. What will you find? Iron and nickel you will find in both outer core and inner core. Okay, these are important. What are the important minerals in mantle and core area? Core also, outer core and inner core. Okay, it is to be divided into two sublayers. Outer core. Okay, you will find here it is divided into two sublayers called as outer core, 2,900 kilometers to 5,100 kilometers, composed of liquid metallic materials like nickel and iron. See here, in the outer core, what you are finding? You are finding nickel and iron in which format? In the liquid format. Understand? In liquid form, you will find nickel and iron deposited in the outer core region in liquid format, and also in the inner core region you will find in the solid format. Okay, and inner core, the solid inner core, 5,100 kilometers to 6,376 kilometers is made up of iron compounds and heavy substances like gold. Understand? Where will you find gold? You will find gold in the inner core. Inner core is the solid inner core which has iron and nickel and also gold in the solid format. This is what we have discussed, and we also saw comparative account analogy of our earth, exactly similar to cut open of the apple. Okay, and you are seeing the outermost crust and mantle area. The fleshy part of the apple is called as mantle area, and innermost the seeded region is called as the core region. In the seeded, outermost seeded region is called as outer core, and innermost seeded region is called as the inner core. Okay, exactly similar. This is what we have discussed. Okay, see here. So this here you can say this is the inner core. Okay, this is the outer core, and this is the mantle, and this is the crust. Understand? That is the uppermost layer is called as crust, mantle, outer core and inner core. Now when it comes to the structure of the internal structure of the earth, what is important? That composition is important. Composition, that means what are the important minerals or materials present in the internal structure of the earth, composition, and also volume, and also the depth. So these three are important. Try to memorize these concepts because these might you might come across in the objective questions also. Okay, you might come across what is the different percentage volume composition of different layers of the earth, and also the depth of different layers of the earth, very important. Okay, only this much. So after this, see, this is what we have discussed, right, previously when we are discussing about Pangea. This is what in the last keyword we discussed about Laurasia and Gondwana, right. So here is the representation of Laurasia and Gondwana. Okay, this part entirely Laurasia, and this is Gondwana. See here, Indo-Australian, this is the Indo-Australian plate, everything is intact, right, everything is intact, Indo-Australian plate, and you will see the ocean encircling, this is Panthalassa, this is around 220 million years ago, this is what we have discussed. Okay, and here Laurasia and Gondwana, and what is this red line? This red line is the Tethys Sea between them. And if I ask you why this Tethys Sea is important, why? See, in this Tethys Sea only, for example, you take this as the whole earth, you take this as the Laurasia, and this is the Tethys Sea, this is the Tethys Sea here, in between here, and whatever rivers are coming from this Angara land or Laurasia, all the rivers are depositing important rich sediments into the Tethys Sea. Okay, so Tethys Sea is completely filled up with all the important rivers coming from this area, all the important rivers, whatever water bodies are there, whatever water sediments are there, all the sediments are brought by these water bodies, and they are depositing here in the Tethys Sea, that we know comfortably, right. Because this Tethys Sea has lot of deposits of these sediments, when these two plates are hitting, all these sediments which are by this time solidified into different rocks, and all these sediments, because of this hitting, they are rising into huge elevated lands, and finally leading to the formation of Himalayas. Okay, that you have to understand. Okay. So this Tethys Sea is also responsible for formation of important landforms or important physiographic division of India, that is called as Himalayas. You will see this much about Himalayas and course of formation of Himalayas in our next year, that is in 10th class. Okay, see here, and this is what we have discussed. And see, this is Africa and this is India. See, you have to understand here. See, this is all Gondwana land, and this is all Indo-Australian plate, cutting, see here, cutting away from the Gondwana land, and that is going and hitting this Eurasian plate. Understand? See here, and this is 220 million years ago, but this is only 135 million years ago. That means it is taking millions and millions of years for these continents to slowly drift apart, and finally placing themselves in a divided format in the present different continents and different seas and oceans across the surface of the earth. Okay, so do you find Tethys Sea now, as we have discussed in the last session, in the last session of our lecture number 4, do you find Tethys Sea here right now? Can you find Tethys Sea in the map? No, because all this Tethys Sea is gone, and all the remnants of the Tethys Sea, remnants, meaning of remnants is that all the different rivers like Caspian Sea, Mediterranean Sea, Black Sea, and Aral Sea, and all such important seas are nothing but the leftover part of the Tethys Sea only. Okay, you can say that all these important seas originated from Tethys Sea, but you cannot find Tethys Sea exactly as of now. Okay, that is what we have discussed, and this is the present 10 million years ago, where many of the like North America, North Atlantic and Europe, many of the continents and Antarctica and Australian plate also finally emerged, and finally they are placed in their respective positions. This is when? This is 10 million years ago, 220, 135 and 10 million years ago. This is what we have discussed, and this is what we have discussed in the last keyword, that is about the internal structure of the earth. Okay, Okay, that is what. So what are the important keywords until now we have seen? Important keywords whatever we have seen are Carl Sagan is over, Big Bang Theory, heliocentric and geocentric, Perihelion and Aphelion, formation of the earth, Laurasia and Gondwana we have discussed, and internal structure, okay, we have discussed, movements of the earth's crust, that is Wagner. Okay, whatever this continental drift theory, whatever we have discussed, that is all about continental drift theory, and also latitudes and longitudes. Okay, latitudes and longitudes, and also time zones. This is also very important last part of our chapter, our earth, which is also very important for our understanding. And we also talked about international dateline, that is called as anti meridian. Okay, so this is the concepts whatever we have discussed, and once again for our understanding and for our examination purposes also, we will talk about latitudes and longitudes once again. That will be the final final time where we are discussing about this particular chapter. Okay, see here. So what is this? Understanding longitudes and latitudes. See here, if I ask you what is the basic benefit of longitudes? What is the basic benefit of longitudes? See, longitudes we can also try to find out the time, place and exact location of anything on the earth with the help of longitudes. There might be a question, and on these imaginary lines called as latitudes and longitudes, because of this latitudes and longitudes there is a grid formation. You have this keyword in your textbook also. What is a grid? See, grid is an intersection lines and blocks which are formed because of the intersection of these two imaginary lines, that is latitudes and longitudes. When these two imaginary lines, latitudes and longitudes, they are intersecting, you will find a grid kind of pattern on entire surface of the earth, which is imaginary, which is virtual, you can't see it exactly, but this grid, each and every grid amounts to certain location on the surface of the earth. Okay, so because of this intersection only we are able to find out the exact location of anything on the surface of the earth. Okay, so you are seeing your Google Maps, right? Your Google Maps and GPS location and all. You will send you please send me your WhatsApp location. You should please share me your location. So when you are sharing your location, what you are sharing there? You are sharing your Google location, right? But how Google is accessing your location exactly? How Google knows that you are sitting in your bedroom? How Google knows that? Google knows that with the help of latitudes and longitudes. Okay, this is all basic application of the latitudes and longitudes. We will also see once again what are these longitudes. Okay, as we have discussed previously, this is see, the latitudes divides the earth into two hemispheres, that is the northern hemisphere and southern hemisphere. And how many latitudes are there totally? You will find 90 latitudes on the northern hemisphere, 90 latitudes on the southern hemisphere, and one single latitude is called as equator. Okay, thus that we know until now. Okay, that is that latitudes are dividing the entire surface of the earth into northern and southern hemisphere. Okay, right? And when it comes to longitude is dividing the entire surface of the earth into two hemispheres, that is eastern hemisphere and western hemisphere. Okay, eastern hemisphere and western hemisphere. How many longitudes are there? How many longitudes you can draw? Totally 360 longitudes you can draw. Okay, 180 here and 180 here, 360 longitudes you can draw totally. Okay, that means if this is the earth entirely, whatever you are seeing, whatever is visible is called as the Greenwich meridian or the central longitude. This is the center Greenwich meridian, which is also called as 0° meridian. From here you will see 180 degrees and here you will see 180 degrees, right? This is what we have discussed. And every rotation of the earth, you can say that earth is rotating how much? Earth is rotating 360 degrees. This is all calculation we did in our last class, right? And when earth is rotating 360 degrees for every 24 hours, because of this earth rotation. We are also rotating how much? 360 degrees, entire earth is rotating. It is taking how much? 24 hours of time. How many longitudes are there totally? 360. Okay, we can say that if it is taking 360 degrees for 24 hours, for 1 hour, if I say that for 1 hour, how many degrees it is rotating? Okay, you can take 360 by 24, you can say that 15 degree. Okay, you can say that for 1 hour, for 1 hour we are rotating how much? We are rotating 15 degree. That means a person who is standing here, after next 1 hour he will see himself within a 1 hour he will see himself moving around 15 degrees, because of the rotation of the earth. Okay, see here, that means for 1 hour how many degrees he is rotating? He is rotating how much? 15 degree, right, for 1 hour. That means 1 hour 15 degrees in 1 hour. Okay, 15 degrees in 1 hour. And if 1 degree is how much? 1 degree is 4 minutes. Okay, 1 degree is 4 minutes, right. See, for every 1 degree of rotation, it is taking how much time? 4 minutes time. So here comes the calculation again. What is the calculation here? Here India, for example, here it is 0 degree longitude, and whenever you see in any representation, you will see that our time is represented like this. Okay, our time is represented like this. That is Greenwich Mean Time plus 5.30. Okay, that is 5 degree 30 minutes. What is this? Do you know this? Greenwich Mean Time and 5 degree 30 minutes. What is that? So Greenwich Mean Time is 0. From 0 degree we are ahead how much? 5 degree and 30 minutes we are ahead. Okay, but we have to understand that what is happening. See, for what is happening here means, for example, for every 15 degree, you are taking how much time? You are taking 1 hour time. That means we can say that if the time here at Greenwich Mean Time, if the time here is, for example, 12 p.m. in India, the time will be 5:30 p.m. right? 5:30 p.m. Okay, that is what. Okay, that is what. And we can say that longitudes are also called as meridians. This is all what we have discussed, and the central 0 degree meridian is called as prime meridian and Greenwich meridian. And why it is Greenwich? It is all because of the Royal Observatory which is located in Greenwich. Okay, that we have discussed. Okay, this is all Royal Observatory which is located in Greenwich. Okay, so British ruled and all this important aspect. And this is what? This is a prime meridian. This is the prime meridian. See here, what is there here? What is here? You can clearly see that is 0 degree, 15 degree, 30 degree, 45, 60, 75. For every 15 degree, how much time it is taking? For every 15 degree, it is taking 1 hour time. Okay, 1 hour, 2 hour, 3, 4, 5, 6, like this, 12 hours, and again 12 hours. That means totally how much time? 24 hours for encircling, for entire rotation of the earth. So this is the basic time period for rotation of the earth. Okay, that is what we have discussed. So this is what, there are 360 longitudes, and there are 2 groups. Eastern longitude 0 to 180 degrees, as you know, 0 to 180 eastern longitudes and 0 to 180 western longitude. Okay, 0 to 180, and earth is moving from west to east direction. That is in the eastern part, whichever countries are there, eastern part of meridian, eastern part of Greenwich meridian, these countries are experiencing a day in advance. That means they are gaining time, eastern part of the meridian. Okay, that means we can say that India is comfortably way ahead than the America, and we can say that Japan is way ahead than India, because that is in the eastern side of India. Okay, so we can say that from Greenwich Mean Time, whichever countries are to the eastern side, they are moving ahead compared to the countries which are in the western side. So 0 degree and 180 degree longitudes do not have direction markers, and longitudes are also expressed in degrees, minutes and seconds. So whenever you are sharing your location, you are sharing in this fashion. For example, 15 degree, 30 minute and 34 seconds. So this is the basic representation. This is not a secret code, this is a basic representation whenever you are trying to represent both latitude and longitude. Okay, 15 degrees, minutes and seconds. Okay, so this is all what we have discussed, and we also discussed about the anti-meridian, which is also called as international date line. When see what is the basic difference, this Greenwich meridian is basically used for the number of hours, like which part of the country has what time, okay, how many degrees ahead of the Greenwich Mean Time, or how many degrees behind the Greenwich Mean Time, by which we can ascertain the time in different parts of the world. But what about the date? So when it comes to the anti-meridian, exactly 180 degrees reverse, this anti-meridian decides the date of every part of this world. Every country has to decide their date according to this international date line only, and you will find a small curve in the international date line just to accommodate certain islands belonging to Alaska of America. These islands are scattered, some islands are to one side of the line and another islands are to another side of the land, another side of the anti-meridian, to accommodate and bring all of them into a single date. So international date line just turned a bit, twisted and then again formed. You can refer this in your map in the textbook also. Okay, this is all about anti-meridian. Okay, so this is all what we have discussed and what we have seen until now. In our keywords, I have discussed most of the keywords related to your chapter, and see, international date line is also finished. So all these are important keywords given in the chapter. By this we are finishing the chapter number 1, Our Earth, class 9, and we will go to our next chapter in our next session. Until then, thank you students, see you in the next session with our next chapter.
Hello, hi students, greetings for the day. Welcome to Classroom TV. Now let us start the class. Find x plus y divided by x minus y if x is equal to 5 by 2 and y is equal to minus 3 by 4. Let us see now. First we will find out what is x plus y, children. X plus y is equal to 5 by 2 plus minus 3 by 4. Okay, so this is equal to 5 by 2 plus into minus is minus 3 by 4. You know the LCM of 2 and 4 is 4 here. So 2 goes 2 times, 2 5s are 10. Minus 4 1s are 4, 1 3s are 3. So this is equal to 10 minus 3, that is 7 by 4. This is the value of x plus y. Now we will find the value of x minus y now. Okay, we will find the value of x minus y, that is equal to x is 5 by 2 minus 3 by 4. This is equal to 5 by 2 minus into minus is plus, this will be 3 by 4. So now the LCM of 2 and 4 is 4 here, 2 2s are 2 5s are 10 plus 3. So x minus y will be 13 by 4. So now what is asking us? Now Let us see now x plus y divided by x minus y. So we got the value of x plus y as 7 by 4 divided by 13 by 4. You know the division, that is a by b divided by c by d. This is same as a by b into, you have to write the reciprocal of the second fraction. The division of two rational numbers is nothing but multiplication of the first rational number with the reciprocal of the second rational number. So this will be 7 by 4 into 4 by 13. Now this is 7 into 4 by 4 into 13, so that 4 and 4 get cancelled and we get the answer 7 by 13. That is the question. Now let us see the similar kind, the second one. X is equal to 1 by 4 and y is equal to 3 by 2. So first we will find x plus y. Let us find x plus y, children. X plus y is equal to 1 by 4 plus 3 by 2. The LCM of 4 and 2 is 4 here. So 4 goes one time, 2 2s are 4, 2 3s are 6. So we will be getting x plus y is equal to 7 by 4 here. This is the value of x plus y. Now let us find out what is x minus y. X minus y is equal to 1 by 4 minus 3 by 2. So the LCM of 4 and 2 is 4 here. 4 goes one time, 2 3s are 6. So x minus y is equal to minus 5 by 4. So now what is asking? Now x plus y divided by x minus y. This is equal to, the value of x plus y we got it as 7 by 4 divided by minus 5 by 4. You know well, a by b divided by c by d is same as a by b into d by c. So according to that, this will be 7 by 4 into 4 by minus 5. There is no problem if you write minus 4 by 5 also. So now this will be 7 into 4 by 4 into minus 5. Now this 4 and this 4 get cancelled. So you are left with 7 by minus 5. We know a by minus b is same as minus a by b. So according to that, this will be minus 7 by so this will be minus 7 by 5. That's all. That is the question. So he has given the values of x and y and he has given some expressions and one operation is given between them. Let us move to the next problem. Divide the sum of minus 13 by 5 and 12 by 7 by the product of minus 13 by 7 and minus 1 by 2. So first we will find out the sum of these two. The sum of minus 13 by 5 and 12 by 7. First we will find this value. So this is equal to minus 13 by 5 plus 12 by 7. The LCM of 5 and 7, 35, both are prime numbers, just multiply them. Now 5 goes 7 times, 5 sevens are 35. So minus 13 sevens are, 13 sevens are is 91 plus 5 sevens are 35, 7 12s are 84. So this will be minus 7 by 35. So if you can further simplify, this is the sum of the two rational numbers are given. Now you need to find the product. Product of what are the two numbers? Minus 13 by 7 and minus 1 by 2. Okay, so now you multiply minus 13 by 7 into minus 1 by 2. So this is equal to, you know the rule of multiplication, multiply both the numerators and multiply both the denominators. Then this will be minus 13 into minus 1 by 7 into 2. So this is equal to minus into minus plus, 13 ones are 13 on 7 twos are 14. So this is the product. Now what is the given question? The sum should be divided by the product. So as per problem, the sum, what is the sum? Minus 1 by 5. This should be divided with 13 by 14. Followed, the sum should be divided by the product. So we know the rule. What is the rule? A by B divided by C by D, this is equal to A by B into D by C. So as per that, this will be minus 1 by 5 into 14 by 13. So multiply both the numerators. Both the numerators, if you multiply, what you will get? Minus 1 into 14 by 5 into 13. So that is minus 14 by 13 5s are 65. That is the sum. Let us see the next problem, children. If 2 by 5 of a number exceeds 1/7 of the same number by 36, find the number. So there is one number, we do not know what is that number, that we have to find out. So that number, 2/7 of that number, 2/5 of that number exceeds 1/7 of that number by 36. What is the number? Let us see how to do this. So as we do not know the number, so let the required number be x. Let the required number be x. Now 2 by 5th of the number. Okay, 2 by 5 of the number. 2 by 5 of the number. This is equal to 2 by 5 into x. That is equal to 2x by 5. At the same time, 1 by 7th of the number. 1 by 7 of the number. So that is equal to 1 by 7 into x, that is equal to x by 7. Now what is the given condition? It is given here as per the problem. 2 by 5 of a number, that means 2x by 5. This is exceeds 1 by 7th of the number by 36. That means this number is 36 more than this. The number 2/5 of the number is 36 more than 1 by 7th. So that will be x by 7 plus 36. So you have to be very careful when you are writing the expression. Now after that it is just general simplification. So now get that x by 7 this side. 2x by 5 minus x by 7, that is equal to 36. Now the LCM of 5 and 7 both are prime numbers. You just multiply them to get the LCM. 5 7s are 35. Now 5 goes 7 times, 7 2s are 14x minus 7 5s are, so it will be 5x is equal to 36. So now 14x minus 5x, that will be 9x by 35 is equal to 36. So from here x is equal to 36 into 35 by 9. This is a by b. If it's transposed to other side, it will be b by a. Now go for cancellation. So x is equal to 36 into 35 by 9. 9 1s are, 9 4s are. So now you multiply 4 into 35, that is be 140. So therefore the required number is equal to x, that will be 140. Therefore the required number is equal to x, that will be 140. Let us see the next question, children. Two pieces of lengths 2 3 by 4 meters and 3 3 by 10 meters are cut off from a rope 11 meters long. So there is a rope, 11 meters long rope is there. In that, two pieces were taken out. They were cut off. What is the length of the remaining rope? What you do, children? First we will find out what are the two pieces they have taken out. We will find the total length of the rope that has been taken out. That value we will subtract it from 11. Is it clear? So now the length of the rope which was cut off, okay. The length of the rope cut off is equal to, what is the first piece length? 2 3 by 5 meters plus, what is the second piece length? 3 3 by 10 meters. Okay. So now convert these mixed fractions into improper. How to convert? You multiply now. 5 2s are 10. 10 plus 3, 13 by 5. 10 3s are 30 plus 3, 33 by 10 meters. Okay. So now the LCM of 5 and 10 will be 10 here. So 5 goes 2 times, 13 2s are 26. 10 goes 1 time, 10 3s are 33 meters. So this is equal to 26 plus 33, 59 by 10 meters of the rope. 59 by 10 meters of the length of the rope that was cut off. So now what is the total length of the rope? Total length of the rope is equal to, what is the total length of the rope? 11 meters. The total length of the rope is given as 11 meters. So now what is the length of the remaining rope? Therefore, the length of the remaining rope is equal to 11 meters, the actual length of the rope. That and 59 by 10 meters already taken out. So you subtract them. 11 by 11 meters minus 59 by 10 meters. Now what is the LCM here? So this is nothing but 11 minus 59 by 10 meters. So the LCM is 10 here. So 11 into 10, 110 minus 59 meters. So 110 minus 59, that is 51 by 10 meters. So you just do the division. 10 5s are 50. So this you will write it as this is improper fraction, you convert into mixed fraction. So then this will be 5 1 by 10 meters. So therefore, what is the conclusion? The length of the rope remaining is equal to 5 1 by 10 meters. Instead of doing them separately, you can also do like this, like 11 minus first piece minus second piece. Directly you can go for that also. 11 minus length of the first piece is 2 3 by 5 minus 3 3 by 10. Like that also you can do. Let us see the next problem, children. The cost of 7 2 by 3 meters of cloth is rupees 12 3 by 4. What is the cost per meter? So this is unitary method. Say suppose the cost of 5 pence is 10 rupees. What will be the cost of 1 pen? 5 pence cost 10 rupees. 1 pen cost how much? What do you do? Total price by the number of pens. 10 by 5. Here also the total cloth is 7 2 by 3 meters, cloth cost 12 3 by 4 rupees. What will be the cost of 1 meter? Just a division. Is it clear? So now what he has given, the cost of 7 2 by 3 meters of cloth is equal to rupees 12 3 by 4. So therefore the cost per 1 meter is equal to, what will be the cost per 1 meter cloth? Total value is 12 3 by 4. This you have to divide with 7 2 by 3. Okay, as it is the cost, so you have to take rupees. Is it clear? You can write it before also. So now this is equal to rupees. Now convert this mixed fraction into improper. 12 4s are 48, 48 plus 3, 51 by 4. Do the same thing here. 7 3s are 21, 21 plus 2, 23 by 3. Yes, you know, A by B divided by C by D is same as A by B into D by C. So as per that, this will be rupees 51 by 4 into 3 by 23. Any cancellations? No. So now this is equal to rupees 51 into 3 by 4 into 23. A normal multiplication. Rupees 3 ones are 3, 3 fives are 15, 4 threes are 12, 92. So rupees 153 by 92 rupees the cost of 1 meter cloth. But it is improper. So convert into mixed. Let us see how will you convert this into mixed. 153 divisible by 92. Obviously one time because 92 twos is exceeding 150. Subtracting now. 3 minus 2 1. 15 minus 9 is 6. So this is equal to rupees. How many times? 1. 3 twos are 61. So 161 by 92. So therefore the cost per meter is equal to rupees 161 by 92 meters. That is the sum. So this comes under unitary method. It will give the price of some quantities. What will be the price of one quantity? Say suppose the questions will be like this. The cost of 5 pence is 10 rupees. What will be the cost of 15 pence? So in that case what we will do? We will find the cost of 1 pen, and that cost of 1 pen is multiplied by the cost of multiplied by 15, so that you will be getting the cost of 15 pence. Is it clear? Now let us move to the next question. Find the area of the rectangular park which is 18 3 by 5 meters long and 18 2 by 3 meters broad. So the dimensions are given. The length of the park is given and breadth of the park is given. And it is also mentioned the park is in rectangle shape. So he is asking us to find the area of the rectangle. What is the formula of area of the rectangle? Length into breadth. Length into breadth is the area of the rectangle. Let us see now. Length is equal to L you take. So length is given as 18 3 by 5 meters. 18 3 by 5 meters. You convert this mixed fraction into improper. So 18 5s are 90. 90 plus 3, 93 by 5 meters. And he has given the breadth. Broad means he has given the breadth. So breadth is equal to that is equal to B. What is breadth given? 8 2 by 3 meters. So this is equal to 8 3s are 24, 24 plus 2, 26 by 3 meters. So now he wanted the area of the rectangular park. So therefore now the area of rectangular park is equal to length into breadth square units. As it is the area, so the units are square units. So now this is equal to, what is the length? 93 by 5 into, what is the breadth? 26 by 3 square meters. So now multiply 93 into 26 by 5 into 3. So 3 ones are, 3 threes are, 3 ones are. So anything, any other cancellations? No. So this is 31 into 26 by 5. So first multiply what is 31 into 26. 31 multiplied by 26. 6 ones are 6, 6 threes are 18. 2 ones are 2, 2 threes are 6. So it is 6, 10, 1 comes here. 6 plus 1, 7, 7 plus 1, 8. So it is 8 not 6. So this is equal to 806 by 5 square meters. Now it is improper. So therefore, the area of the park the rectangular park you can take is equal to, how much we got? 806 by 5 meters square. Now do the division. 806, you go with 5. 5 ones are 5. 3 0. Okay. 5 6 are 30. 6 left here. 5 ones are 5. 1 left here. So now what we get here? 161 remainder and the we have to write the quotient, remainder and divisor, meter square. This is the area of the garden. Is it clear? Now let us see the next question. What number should minus 33 by 36 be divided to get minus 11 by 4? So there is some number given. It should be divided with some other number so that you will get some result. What is that number needed? So we will start the problem. Let the required number be x. Okay. So now this minus 33 by 36, this minus 33 by 36 should divide with x to get minus 11 by 4. That is the question. So as per the problem, minus 33 by 36, which is divided by x, so that you will be getting minus 11 by 4. Okay. So now you know very well, minus 33 by 36, if you want to divide, then it will be into 1 by x. You have to reciprocate. This is equal to minus 11 by 4. So this is equal to minus 33 into 1 by 36 into x, that is equal to minus 11 by 4. The product of two rational numbers is the product of numerators by product of denominators. So this is equal to 33 into 1 is 33, 36x is equal to minus 11 by 4. So both sides you can cancel the minus. So now do the cross multiplication. 33 into 4, that is equal to 11 into 36x. Just cross multiplication. This will come here and this will go there. So now you wanted x. Keep the x there and bring everything this side. This will be 33 into 4 by 11 into 36. This is equal to x. Is it clear? Now go with the cancellation. 33 into 4 by 11 into 36. 11 ones are, 11 threes are. Now 4 ones are, 4 nines are, 3 ones are, 3 threes are. So therefore x is equal to 1 by 3. So you should divide minus 33 by 36 with 1 by 3. You will get the answer minus 11 by 4. So therefore minus 33 by 36 should be divided with 1 by 3 to get minus 11 by 4. To get minus 11 by 4. That is the question. That is how we have to solve it. So unknown number you have to take it as x. Now let us see the next question. If 36 trousers of equal size can be attached with 64 meters of a cloth, what is the length of the cloth required for each trouser? Similar to unitary method. See, 64 meters of cloth we have. Total cloth available 64 meters. How many trousers? 36 trousers of same size. All the trousers are of same size. Now what is the cloth required for each trouser? Now let us see. Length of the cloth available is equal to 64 meters. The length of the cloth available is equal to 64 meters. Now let us come to the number of trousers. So how many trousers? Is equal to 36. So therefore length of the cloth required for each trouser. Here same size now. Remember, same size. The trousers are of same size. Is it clear? So therefore the length of the cloth are required for each trouser. This will be 64 divided by 36. So we know A divided by B is nothing but A into 1 by B. So as per that 64 into 1 by 36. So this is equal to 64 into 1 is 64 by 36. Go for cancellation. 2 3s are, 2 2s are, 2 1s are, 2 8s are. So now again 32 by 18, it can get cancelled by 2 again. 2 9s are, 2 16s are. So you are getting 16 by 9 meters. So as it is an improper fraction, convert into mixed fraction. 16 by 9, just divide it. 9 ones are 9, you get 7. So it is 1 7 by 9. So therefore the length of the cloth required for each trouser is equal to 1 7 by 9 meters. That is the sum. Same using our unitary method. Let us see the next problem, children. When the repeating decimal 10.363636 is written in simplest fractional form p by q, find the value of p plus q. That is the question. So here what we have? We have a non-terminating repeating decimal. As we have discussed earlier, this case comes under after the decimal point, all the digits are repeating 363636. All the digits are repeating. So that is a pure recurring decimal. So first what we have to do, we have to convert that pure recurring decimal into p by q form, and after converting he is asking us to find the values of p plus q. So you will get the p by q form, so you add both p value and q value so that we will be getting the p plus q. Let us see now how to do this. As 10.36363636 is given, so let it be x. Let x is equal to 10.363636 is given like this. Is it clear? So you take this as equation 1. So now you know this x is nothing but 10.36 bar. What is x here, children? The x is 10.36 bar. The bar is on both the numbers 36. The bar is on both the numbers 36. So what is the periodicity here? What do you mean by periodicity? The number of digits in the bar. So how many digits are there in the bar? 2 digits. So then you multiply the given with the number of zeros after 1. What is the periodicity? 2. So 2 zeros after 1 is 100. So now multiply equation 1 by 100. So what you will get here? 100 into x, 100x is equal to 10.363636 so on into 100. Now this is equal to 100 into x, 100x. The point will move 2 places right when you are multiplying. Only one thing you remember here, when you multiply with multiples of 10, the point will shift right side. When you multiply with the multiples of 10, the point shifts right side. When you divide with the multiples of 10, the point shifts left side. This is the thing you should remember. When division left side, multiplication right side. So here you are multiplying with multiple of 10 having 2 zeros. So the point will shift 2 places right. So now move it. So it is 1036.3636 so on like that it comes. And one more important observation here. After the decimal point in equation 1 and 2, see after the decimal point, the recurring part should be same. The recurring part in both the cases it must be same. Whether it is same or not you have to verify here only. So now in equation 1 I got it 0.363636 and in equation 2 also I am getting the same 0.3636. So now subtract equation 1 from equation 2. You have to subtract equation 1 from equation 2. So now we will write equation 2 first. 100x is equal to 1036.363636 so on, and x is equal to 10.3636 so on. Now go with subtraction. 100x minus x, 99x is equal to, here after the point both are same, so you will be getting 0 here. So 6, subtract it, 3 minus 1, 2, so it is 1026. How much we get it here? 1026, so 99x is equal to 1026. Therefore, x is equal to 1026 by 99. That is, what is your x? Your x is 10.36. Bar is equal to 1026 by 99. Now, this is in the form of P by Q. So, it is in the form of P by Q with P is equal to 1026 and Q is equal to 99. We have a numerator as well as denominator. Now P plus Q. P plus Q is equal to 1026 plus 99. You add both of them. 6 plus 9 is 15, 1 carried here, 10, 10 plus 2, 12, 1 carried here, 0 plus 1 and 1. So it is 1125 is the answer for P plus Q. How much is P plus Q? It is 1125. So like that you can ask P minus Q also. P square minus Q square, P cube minus Q cube, like that anything can be asked. So now here what is important? The conversions. We have done so many problems like this before, and let us check this answer with our easy method. What is the easy method, children? We have what is the point given? X is equal to 10.36 bar is given. 10.36 bar is given. So now you write the complete number. What is the complete number? 1036. Subtract the number not in the bar. What is the number not in the bar? 10. By, what is the periodicity here? What do you mean by periodicity? The number of digits in the bar. How many digits are there in the bar? 2 digits. So 2 nines. So now subtract it, you get 1026 by 99. Now we have to find out the value of P plus Q. Like this also you can do, but this method you have to use to verify it. So you have to practice some random, like this you take like 1.45, the bar is for 5, like that you practice. So with this we have completed the exercise successfully. We'll see you in my next class. Stay tuned and do not forget to watch classroomtv.in.
Hello students, today we are going to look at letter writing. Okay, now do you children have the habit of writing letters? Do you? Have you ever written a letter before? Okay, so in our class today we are going to read a letter that is written to a friend, and I'll also tell you how we can write more letters like that. That way I want you all to write letters to your friends too. Right now, because of this pandemic, we are all at home, aren't we? Yes, because of this coronavirus, we are all at home. Why don't you write a letter to your friend? Isn't that a good idea? Yeah, so today we are going to go ahead and look at a letter written by a friend to another friend, and this is prescribed, this letter, a letter to a friend is prescribed to the 8th class students of SSC, that is SCERT board. Okay, and let's go ahead and look at this letter. But before we look at this letter, let's talk about something very important. Yes, do you know that there are 2 kinds of letters? Do you know that? Yes. we have two kinds of letters. Now, what are they? The first type is your formal letter and your second type is your informal letter. What is a formal letter? A formal letter is a letter written to somebody whom you don't know or who is not your relative. Okay? For example, when you write a letter to your boss, okay, you don't work. So imagine your father, okay, your father is working, right? Yes. And imagine he is supposed to write, he has to write a letter to his boss, to his manager. Now, writing a letter to his boss or to his manager or to anybody who's superior or anybody whom he's working along with, his teammates, that is again a formal letter. Okay, you can write your superiors, to somebody, to subordinates, to your teammates, anything, anyone, but they are still called as formal letters because formal letters are written to people whom you're not closely associated with, you're not friends and you're not relatives. Then those are formal letters. We have another type of letter and that is called informal letter. And what's an informal letter? An informal letter is one which is written to a friend or to your cousins or to your family members, anyone. When you write to somebody whom you're very, very close to, then that's called an informal letter. Now, when you write a letter to your class teacher, what kind of letter would that be? A letter to your class teacher? Yes, you are right. That's a formal letter because your class teacher is not your friend. She's not your mother. She's not any of your family member. Yes. Imagine you're supposed to write a letter to the principal of your school. What kind of letter would that be? Yes, that's a formal letter. Okay, imagine one of your cousins is living in Dubai and you have to write a letter to that person or you are writing a letter to that cousin who is in Dubai. What kind of letter would you be writing? Would that be a formal letter or an informal letter? Yes, that would be an informal letter. Now, here in the next picture, I have a set of two pictures. I have two pictures here and one picture is a formal letter and the other one is an informal letter. We have two letters. Can you people tell me, can you students tell me which one is formal and which one is informal? Yes? Very good. This is formal and this is an informal letter. Now, let's go ahead and look at the way a formal letter is set up. Look at the structure of the formal letter and look at the structure of the informal letter. Yes, a formal letter is much smaller. And this is a formal letter. Yes, let's go ahead and label it formal letter. This is a formal letter and this here is an informal letter. A formal letter, look at the size. You can't talk much. You must not talk whatever you want to. You cannot just talk about your town, country, etc. in a formal letter. You have to be, it should be to the point, direct and to the point because they don't have time to listen to our nonsense. Yeah. Whereas an informal letter, it can run to how many pages you want it to, but still, if you make it brief, it's much more easier for the person to read and, to have fun while reading. If it's a very lengthy letter, they may not find it interesting. So, a formal letter, look at the way the addresses are, look at the way the address is actually given in a formal letter. This is your from address. So, when it comes to a formal letter, you have this structure. This is called a block format where everything is on your left hand side. Yes, everything is on your left hand side. You have the from address, you have date here, and then we have the to address. Okay, from, date and to. And then we have the subject. Subject means what are you writing about? What is the letter about? That is subject. Very, very important in a formal letter. And then we have the salutation. Dear sir, dear Mr. Singh, dear whatever. But you have to write, you have to address them with their titles. You cannot just, talk about them randomly. You cannot say, hey, Matthew, how are you today? You have to use their titles. Mrs. So-and-so, Mr. So-and-so. You have to use their full names. Okay? Here we have the salutation. Then this is the body of the letter. 3 paragraphs. How many paragraphs do we have? We have 3 paragraphs. Introduction, body and conclusion. This is the body of the letter, and then we have the closing statements. Okay, so sincerely, name, and then whatever your designation is. This is the formal letter. But when you compare the formal letter to an informal one, look, we do not have the addresses there. We do not have the complete addresses mentioned in your informal letter. What do we have? We just have Hyderabad, okay, the name of the place that you're writing from, and we have the date. Name of the place and date. These two are very important. Though it is a informal letter, you must still go ahead and write name of the place and date. Then we have Dear Suresh. How is the letter addressed? To whom is the letter addressed? Suresh. And how is it addressed? Like, do we have Mr. Suresh? No. Do we have Suresh, with the last name? No. We just have Dear Suresh because they are friends. When you're writing to a friend, you can just address them by their first name. You don't need their surname. You don't need their last name. But when you're writing a formal letter, you do need a surname. Then we have the body of the letter. But look at the body of the letter. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost 9 to 10 paragraphs we have here. But here we only have 3 paragraphs. As I told you, formal letters are much more smaller, shorter in length, and an informal letter is bigger. Now we have the complimentary clause again over there. And complimentary clause, you have your loving friend Ramesh. Your loving friend Ramesh. So we don't have, it's not like, sincerely, name, and then, the designation. We just have the who is, your friend, complimentary clause with your name. That's it. We don't have to mention our designation again. So these are a few differences. I'll point out the differences again when we are actually working on our letter. Okay. So here we have a letter, and I want you to kind of, use this kind of writing in your day-to-day activity. At least if not day-to-day, at least once in a month, write a letter to someone. Okay. That will help you improve your writing skills. Very, very important. Okay. So let's go ahead and look at our letter. A letter to a friend written on 12th of November 2012. 12 November 2012. And when is it where is it written from? It has been written from Hyderabad. Okay. Dear Suresh, this is Ramesh. I apologize for not meeting you during your visit to Hyderabad last week. Unfortunately, I had a meeting in my office. I remember how we enjoyed our childhood days in Manikonda village. Every day we played together in our garden. Our family was very big. There were 12 members in our family. I remember how we played in the moonlight. Our grandma used to give us fruit and biscuits. Our grandpa used to tell us fairy tales about the princes, warriors, and the village boys. So here we have, there are two people here, the one who is writing the letter and the one who is receiving the letter. Who is the one writing the letter? Ramesh. Ramesh is writing the letter. And whom is Ramesh writing to? Yes, he is writing to Suresh. Ramesh is writing to Suresh. And Ramesh, why is the reason that he is writing this letter? In the very first line we come to know that. And in the very first line he says, I apologize. That means I am sorry. I am sorry for not meeting you during your visit. That means this boy here, this man this man here, Suresh, he came to Hyderabad, and when he came to Hyderabad, probably he wanted to meet his good friend Ramesh. But Ramesh could not meet Suresh, and that is the reason he actually begins writing this letter. Okay, so he starts off by saying that I'm very sorry I couldn't be there. You have visited Hyderabad, and because of my busy schedule, I could not visit you. But I do remember. What does he remember? He says, I had a meeting in my office. Why could he not meet Suresh? Because he had a meeting. He was busy. I remember. What does he remember? He remembers his native place, or his native place. Probably he is a native of Manikonda village. Okay, it's in the state of Andhra Pradesh, and from there he probably he lived there during his childhood. And he and Suresh, Ramesh and Suresh, were good friends, and every day they played with each other in their garden, and they had how many members in the family? 12 members. He's trying to recollect. He's trying to recollect the times that he had spent with Suresh. Okay, so he's talking about how that they had fun, how that there were people, many people in the family. 12 members in a family is not something that's common these days. How many members do you have in your family? You can count. Yes, on your fingers you can count, I think. Yes, 3, 4, 5, 6, not more than that, I'm sure. Yeah. Okay, so there were 12 people in his family, and he remembers how that they had played in the moonlight, in the garden. They were playing all the time, okay? And he remembers how that his grandma used to give him fruits and biscuits, okay? So that means grandma and grandpa also lived with them. That's a joint family. Remember when we did the tattered blanket, I told you what's a joint family and what's a nuclear family? Today most of us are having nuclear families. But here Ramesh is talking about grandpa and grandma. That means they lived in a joint family, and their grandparents were very much loving, and they gave them food to eat, and grandpa used to tell them a lot of stories. We like stories, yes? Yeah. Now the next paragraph. Now I'm working at Microsoft, a software company in Hyderabad, as a computer programmer. I am married and we have a child. My wife works at Dell, Hyderabad, as a system analyst. City life is quite busy. We start in the morning, leave our child at the baby care center, and come back in the evening with faded faces. We hardly find time to sit together. How disgusting. We work with computers, think like computers, and live like computers. We have forgotten our family. So he says that, in the first paragraph, he talks about how family has, how he was a great enthusiast of a family, how that he really loved being in a family and playing with family members. In the second paragraph, he talks about how life changed. Life changed. Okay, and how did Ramesh's life change? Well, he got a job. Okay, he's working at Microsoft, a very big company. He's a computer programmer. That means he writes codes. Okay, he develops programs using coding. So he's a computer programmer, and he's also married now. Okay, he's married, he's working, his wife is also working. That's how these days are. These days husbands and wives, mothers, fathers, everybody works these days. Yes, so husband is working, wife is working, and it seems they start off early in the morning. Okay, very early in the morning they start off. They also have a child. So look at the way Ramesh's life changed. Ramesh used to live in a small village called Manikonda village. From there he moved to this city called Hyderabad, where he now has a job. He's working for Microsoft. He has a wife who's working for Dell. Dell is again a very big company. Dell. It's a very big company, and she's working for Dell as a system analyst. That means, she tries to analyze the problems that exist within the business, and she tries to fix them using information technology. Using IT, she tries to solve business problems. That is what system analysts do. Okay, so here he is working as a computer programmer. Wife is working at Dell as a system analyst. And child, they have one child, and they leave the child at the baby care center. Okay, and he talks about how that their lives are so busy. They come home with faded faces. Faded means tired. They come home with tired faces. Yeah, we can kind of, imagine our own parents doing this actually. Yeah. They come home with faded faces, and we hardly find. What does hardly mean? Never. Hardly means never. We never find time to sit together. How disgusting. Disgusting means bad. Life's horrible. Yeah, so we work with computers. Well, computers are inanimate objects, they don't have life, they're non-living things. We are working with non-living things, and we are thinking like non-living things, because non-living things don't have feelings, do they? Do they have feelings? No, they don't. And because we are working with computers all day, even our minds are kind of, getting so, we are not able to think about things that are really important. We are only able to think like computers and work like computers. That's it. And we have forgotten the family values. I remember how we played gilli danda, hide and seek, and kabaddi. We went for swimming in our local tank every Sunday. Here we live in an apartment where there is no room to play. Our flat is our world, just like a well for a frog. The world remains unheeded. How happy we were in our school. We used to sit in the same row, did all the work together, and took part in the events. I remember how Padmanabhaya sir, our class teacher, appreciated us when we got the first prize in district science fair. So now he's remembering his childhood days, the days that he spent with Suresh. Okay, so now Ramesh says that I remember how we played gilli danda. You know what's gilli danda? Do you play that game? Yeah, this is gilli danda, where there's a small stick, and along with another big stick you need to play with it. I'm not really sure of the rules, but yes, that's gilli danda. And most children, when we were kids, they used to play this game, but I'm not sure about today's generation. Okay, so he talks about how that they played, how that he played gilli danda along with his friends, how that he played hide and seek. Yeah, we love to play hide and seek too. Yeah, hide and seek and kabaddi. What is hide and seek, guys? Do you know what's hide and seek? You hide and somebody finds you, and again you count 1, 2, 3, 4, 5, 6, 7, and then somebody finds you. That's called hide and seek. Okay, so he's talking about those days when he enjoyed playing gilli danda and hide and seek and kabaddi, and they swam in the local tank, not in the swimming pool, guys. Okay, and he's comparing those days to today's days, and he says that today we are living in an apartment and we don't go anywhere. Okay, we don't go anywhere, and there is no place to play. We live in a 2-bedroom apartment and there's no place to play here and there, and we don't go and play gilli danda on the streets. Yeah, that's something that we cannot do anymore. And our flat is our world. Like, we're just living in that flat and we don't go anywhere else. It's like, a frog in a well. Okay, and the whole world, we don't know anything about what's happening in the world and how to actually go and have fun in the world. And then he talks about his school days. He's talking about his childhood days, guys. Okay, how he spent after school, I think, here. And now he's talking about how he spent school days with him. So they went to the same class, sat next to each other, and he talked about his class teacher also. He's remembering his teacher. Do you remember your teachers? Yeah, teacher who taught you in first grade, second grade. Yes, he's remembering his teacher, and he is talking about how that class teacher has appreciated them when they got some kind of a prize, a first prize in district science fair, district science exhibition. Have you ever participated in a science exhibition? Yes, do you know what I'm talking about? Yes, you can create models, science models, and you can display it, and people will come and they'll ask you a few questions and you can tell them what it is and how it works and etc, etc. That's a science fair, and they got first prize. So that shows that they are intellectually smart. They are clever students. Who? Ramesh and Suresh. That's why they do have, they got a job as, that's why Ramesh got a job as a computer programmer. No wonder. I remember how we went on a picnic to Coil Sagar. There we went boating. Our tour to Sri Salem was memorable. Still, I remember the green hills full of trees that almost touched the sky. I remember the roaring of the Krishna river at the dam. There is nothing here. I wonder at my child's silence. He always sits in front of the computer and plays games, never caring for anyone. Now he talks about the trip that they have taken to Sri Salem. Yes, that's again in Andhra Pradesh, in Kurnool of Andhra Pradesh, and there they have a big dam. Have you been to this place, Sri Salem? Okay, it's called Coil Sagar, and there they have visited this place, and it's so much fun to see water that's just gushing out of the dam. And he remembers that time where he had lot of fun at that picnic spot. He talks about how that they went boating. Yeah, in the water, they went boating, and it's so, he's remembering all those days and thinking about the fun that they had, and he's thinking about his son who doesn't have any fun anymore because he doesn't have friends. They're living in an apartment, there's not many people to play along with because all of them are living that kind of a busy life in the city. Hyderabad is a city. So most people in Hyderabad have busy lives. They don't have time to go and play in the water. They don't have time to play gilli danda. They don't have time to play hide and seek these days, and especially people who live in the apartments. So he's saying that my son, now I understand why my son is so silent. He's so silent because he doesn't have friends to play with, and the only friend that he has is his TV. Yes, these days all of us are hooked to TVs. Yes. So my son also watches TV and whiles away his time, and he plays a lot of games. That's it. Okay, so the only interaction is the interaction with the screen. That's the only interaction that today's generation has, and that is the reason most of us, we are unable to actually say what we think. Try that. Try saying what you think. Try, saying it in English. I'm saying, I'm not talking about being talkative, but try to talk about any topic in this world. Take any topic for that matter. we came to know that, our singer and actor, he passed away, Mr. Balasubramanian sir. Can you talk about him? Can you talk 5 lines about him? If you cannot, you can understand that we are kind of short when it comes to our intellectual smartness. Okay, we may be intellectually smart, but there is no, we cannot talk about anything to anyone because we are tuned that way. We have just the 4 walls around us and we are always interacting with the screen. No friends, not much to talk about, not much to think about. But from now onwards, try doing that, guys, as an exercise. Think about someone or something that happened that day in the news and try to talk about it to someone at home. Or call up someone and talk to them, to your friends or to your neighbor, someone. But talk. Okay, talk in English. Speak in English. I remember the happy times when our uncle visited us. He brought toys and fruits for us. Our aunt brought me a new dress for Dasara. How we enjoyed Deepavali. Still I hear the sound of crackers. I can see the rockets flying into the sky, making the night full of light. Where are those days? My child doesn't know his aunt or uncle. For him, uncle and neighbor are the same. So he's talking about the festivals that he celebrated at Manikonda village when he was young, when he was little. How that his aunt and uncle gave him gifts and clothes, yes? How he celebrated Dasara and Deepavali and the firecrackers. So much fun and so much enjoyment with friends and family. That kind of bond is something that is missing in today's generation. And he says that my son doesn't know his aunt or uncle. He knows his uncle, as much as he knows the neighbor. The neighbor is his uncle, that's it. But nothing more than that. He doesn't know his aunt and uncle the way he actually should. Why? Whose fault is it? Is it the child's fault? No, it's the parent's fault. The parent is so busy with work that he's unable to take time to take his son to his aunt or his uncle, etc. Everybody's busy. Not just your parents, guys, okay? Everybody's busy. Sometimes I think of our childhood days. I think of grandparents, uncles, brothers, sisters, etc. We miss them. We miss the joy of the family. We miss their company. We are missing many things in this busy life. Suresh, I don't know where those gardens have gone, those fairy tales, those fruits, those words of love and affection. We have lost our real life in this unreal world. Anyhow, I'm happy that I have found time to write to you. Please come to me. Let's remember our childhood days of joy. So now he's talking about how that he's concluding his letter. He says that he misses everything. He misses family, friends. He misses the days of joy, the days of happiness that he spent with that family and friends. Okay, he talks about how that, everything is just so, lost. He lost everything in this unreal world. There are so many photographs, selfies that you take every day. And those selfies, even if you're not happy, for the selfie you say, yeah, cheese. But actually you may be, crying inside. You see so many pictures with so many beautiful faces smiling. But that is so unreal. Do you know that? Do you know that? That is so unreal. It's so artificial. The world we are living today is so artificial. Nothing is real, guys. And in this unreal world, we have lost touch with family. We have lost touch with happiness. And he says that I'm very happy that finally I got time to write to you and to remember our childhood days. So why don't you come once, sometime whenever you're free, come and we'll again think about these childhood days. And it says, your loving friend, Ramesh. Okay, so let's go ahead and let us see how that this letter qualifies to be an informal letter. Yes, as I told you, an informal letter you just use, in an informal letter you just use names. Yeah, you just use names, and here we are using Suresh. No Mr., no title, no sir. That's an informal letter quality. Okay, the other one here is just like a well for a frog. Now here, this is something that you have to have some background knowledge of. Okay, this requires background knowledge because this is something that we Telugu people use, okay, or we Indians use. This is an idiom that we Indians use, like a frog in a well. But that is something that is not American, that is not some, non-native speakers of English, Americans, Europeans, they don't understand this phrase because they don't have this in their regular language. But these can be used in an informal letter because you're writing to your friend, so he has some background knowledge. But if you write this, you cannot write this in your formal letter because they don't know about what you're saying, especially if they don't have the same kind of background. Okay, so let us look at the next one over here. Sometimes I think of our childhood days, I think of grandparents, uncles, brothers, sisters. You have ... over here. Yeah. So, incomplete sentence. Can you have incomplete sentences in your formal letter? No. You cannot have incomplete sentences in your formal letter, but you can have incomplete sentences in your informal letter. Okay. Then one last one, guys. Yes, we have exclamations. Exclamatory marks are used in your letter too often actually. You have many exclamatory marks. Okay. And that is again something used only in your informal letters. We never use this in our formal letters. Don't. In our formal letter, we must always say do not. But in informal letter, that's okay. Don't is fine. Okay. So these are a few qualities of an informal letter. So try writing informal letters during your free time. Okay. I have not taught you how to write a formal letter yet. I'll be teaching you in the next few classes. But here we have an informal letter, and try to use that, try to write informal letters to any of your friends and make a habit of writing. Now, let's go ahead and look at the comprehension questions. Now, this, please remember that this particular lecture over here, this particular lesson belongs to part C of your unit 1. Under unit 1, we had the tattered blanket, which we already finished. My mother completed, and now we have looked at part C, a letter to a friend. Now, part A and part B, you are questioned in your examinations, whereas part C, it's for pleasure reading. You read just for fun. So, here when we read just for fun, it is more about how much we understand. So, therefore, we have a comprehension check. We have to check how much we understood. Comprehension means understanding. Okay. So, how much did you understand is what we are going to check right now. So, how did Suresh and Ramesh spend their childhood? Yes, they had lot of fun in their childhood. Remember? Yes, they used to play gilli danda, hide and seek. They used to swim in the tanks. They used to go to the same school, sit next to each other. They participated in a science fair. They were appreciated by their teacher. So many things that they did. They spent festivals together. Grandpa used to tell them stories. Grandma used to give them fruits and biscuits and all kinds of nice things. Yes. So this is how they spent their childhood. Second question, why did Ramesh's family move to the city? Yes, Ramesh's family moved to the city because he got a job there. He was working for a big company, Microsoft, and therefore they had to move to the city. What change did you observe in Ramesh? Yes, at the beginning we see that Ramesh, when he was a young boy, we find that Ramesh was very much close to the family. He loved his mummy, he loved his papa, daddy or Nana. Yes, but as time progressed, he lost that touch. Though he wants it, though he loves his family and friends, he doesn't have time. He's too busy. And that is how his life changed. Now he has no time for family and friends. Do you think Ramesh is happy in the city? Why? Well, Ramesh may be happy because of the job, but otherwise he is not so happy with the city because he is not able to have that kind of a fond relationship with family and friends. Yes, he finds that his own son right now doesn't share that kind of a relationship with family and friends. His son doesn't know half of the members of his family. Yes, so he doesn't like living in the city, but is forced to live in the city because of his job. Last question, what made Ramesh write to Suresh? Yes, what made him write a letter? Yes, the reason he wrote a letter to Suresh is because, yes, Suresh came to visit Hyderabad, and on his visit there, I think he probably called up Ramesh and said, hey Ramesh, shall we meet, shall we talk? And probably this fellow said yes, and then he couldn't make it, I think. Okay, and to apologize, to say sorry to Suresh, Ramesh wrote this letter. So when you do part C reading, I want you to read and I want you to check how much you understood. Now, let's go ahead and look at this particular project work that I want you all to do. Yes, you have to do this project. Now here, each lesson of Unit 1, each lesson is talking about family. Yes, it's talking about how that, families have changed over a period of time. At the beginning, most of us lived in joint families. We had our grandparents living with us. But today, it's not so common to find grandparents living in your house. Yeah, you can see, check that in your own house actually, at your own place. Not many of us have our grandparents living with us. So, in part A, part B and part C, the same idea of family values is being discussed. Okay, the tattered blanket talks about how the son has forgotten his mother because of his busy life, and how that the mother forgot the son because of her physical illness. Yes, though the mother is very fond of the son has never visited the mother for 6 years now. And the mother kind of, because of amnesia, because of forgetfulness, she forgot her son. But her son, though he is hale and healthy, doesn't have time to visit the mother, and he forgot his mother. Sad situation, family values have gone down. Degradation of family values, deterioration of family values. In the second one, My Mother, written by Rabindranath Tagore, we see that Tagore lost his mother when he was a young boy. He doesn't remember how his mother looks. He doesn't remember how his mother smells. He doesn't remember how his mother looks at him, stares at him. He doesn't remember all these things, but still he's fond of his mother. He loves his mother, and everything that is around him reminds him of his mother. So there we see that he loves his mother, he appreciates his mother, he misses his mother, and we see that he is a son who is a responsible son. A responsible son who loves his mother. In the tattered blanket, it was Gopi, an irresponsible son who did not care for his mother. In My Mother by Tagore, we have a son who is loving and who loves his mother, and if she were alive, I'm sure Tagore would have taken a very good care of him. A responsible son. And here in part C, we have a letter to a friend which is talking about how today families are not together, as far as, they are very far from each other because of our busy schedules. Okay, so your project work is observe any 5 families in your own neighborhood. In your neighborhood, you have many families. Yes, take any 5 families, jot them down. Family number 1, so and so name. Read their surnames. Okay, surnames are your last names. If it is like P. Sunita, then whatever P stands for is your surname. Yes, so take the surnames. Family number 1, the something. family number 2, family number 3, family number 4, family number 5. And then draw your conclusions, advantages and disadvantages of living in a joint or nuclear family. Then, after writing family number 1, mention whether that's a nuclear family or a joint family. And after you make note of all those, for all the 5 families, mention whether it's joint family or nuclear family, joint or nuclear. Okay? And finally, draw your conclusions. You tell us whether living in a nuclear family is better or a joint family is better. Guys, both are good. It's not that nuclear family is bad. It's not that joint family is very good, or vice versa. Each of them have advantages and disadvantages. So I want you to make a list of advantages and disadvantages, and maybe you can send it to us. Okay? Send it to our email. You can email that to us. You can take a picture, or you can do it in a Word document and send that document to us. Okay? And if it's very good, I will discuss it in the in our channel. Whenever I take your next class, I'll discuss it here. Okay? So think about these things, guys, and always love your family. And even if you reach great heights, if you become a great person in your life one day, always remember that family is the reason you are at the place you are right now. Okay? In the future, always remember that because of your family, you are what you are. And therefore, give importance to your family, love on your mother, love on your father, your brother, your sister, love everybody, guys. And keep loving on them. Show them that love. Okay? And keep watching us on Classroom TV.
Dear students, welcome back to Classroom TV. We ended the previous session with a challenge regarding how to simplify the process of drawing normal to the curved mirrors. We were looking at drawing normal to the plane mirror, and we want the same simplicity, same ease with which we can draw the normal to the plane mirror that should be there while drawing the normal to the curved mirrors or spherical mirrors. And we had seen that while drawing normal to the plane mirrors, either a horizontal line or vertical line can serve as a normal. But for curved mirrors, that's not the case, because curved mirrors are neither vertical nor horizontal. Therefore, at any given point, the normal will have to be an inclined line. The problem is that through a point you can draw a number of such inclined lines. Each line will say that it is a normal, but what is the condition for a line to be a normal? That it should be perpendicular to the mirror at that point. So amongst all these many inclined lines, you have to search for that line which is perpendicular to the mirror at that point. And this process appears to be complicated. We want to simplify this process. Directly, if we can identify that the particular line, particular inclined line will always be normal, no matter where the incident ray is striking, where the point of incidence is. The incident ray may be striking here, anywhere on the curved surface, the incident ray might be striking, and at that points there will be number of inclined lines, and amongst them we have to find out which line is perpendicular to the mirror, and that line will be the normal. So here we will make use again of the geometry of the sphere. This curved mirror is a part of the sphere, and you know that sphere on a paper is represented by a circle. So when you want to represent a sphere, you will draw a circle. So this circle represents the sphere now, out of which the spherical mirror has been carved out. So that means here this will be our curved mirror, this can be your curved mirror, this can be your curved mirrors. So anywhere along the circle you can carve out the spherical mirror. But now we will use this geometry of this circle which is representing the sphere to find out how to draw a line perpendicular. That means any point here on this circle, how to draw a line which is perpendicular to the circumference of the circle. So in this we will make use of one important theorem regarding circles. That theorem is radius tangent theorem. What it says is that if you draw a tangent to the circle, then at the point where tangent meets the circle, you draw radius. So you have two things here, tangent and radius. And this theorem, radius tangent theorem, this radius tangent theorem says that the radius and tangent are perpendicular to each other. They make 90 degree. The angle between them is 90 degree. Now can we use this? You should think in this way. This is a fact you have learnt now. You may be knowing it already. But try to think how can you use this for the spherical mirrors, curved mirrors. What we want to find? Normal. We want to draw perpendicular. So using this, let's check out how to accomplish the task at hand now for us. So here at different points we have drawn tangents. At different points we have drawn tangents, and where the tangent meets the circle, that is called as point of tangency. Now again we will try to make use of this point. We already know that from anywhere we can cut the curved mirror here, spherical mirror here. So our spherical mirror might be this, it can be this, anywhere. So suppose this part is what we have taken as a mirror. We have carved out this part and this part we have removed, and this is now our spherical mirror. Whole circle is still there, and now we are considering our mirror along with the circle. So let us say this at this point of tangency, one light ray is striking there. So now this point of tangency is now becoming point of incidence. Already at this point, ready made for us, we have a line which is perpendicular to the circle, and that is the radius as per the tangent radius theorem. So we have selected the point of incidence itself to be point of tangency, and ready made we are getting a normal, ready made we are getting a perpendicular. So that means at the point of incidence, remember this is whole circle is there, and out of that circle AB part we have taken, which is the arc, which is curve, and it is serving as a concave mirror, and we have managed to draw a normal at one particular point. In this way, suppose now that AB we have turned it little. So here again is A and B, and at other point the ray is striking. So incident ray is striking in this way. This is incident ray, and now what we should do? We are now beginning with incident ray. Now we are beginning with incident ray. Next step is at the point of incidence you draw a tangent. First incident ray is there. This is point of incidence. At the point of incidence you draw one tangent. Then you draw the radius from that point. So you have drawn the radius, and as per tangent radius theorem, this radius will be perpendicular to the circle at this point, which is also point of incidence. So that means now we have got a normal at the point of incidence. So any other point now, suppose this is the mirror A, B, and here incident ray is striking. Draw a tangent there. draw the radius. So that radius itself will behave like a normal. Now let's call the center of the circle as C. So C is the center of the circle, and now if we have taken a part of that circle as a mirror and also we are taking this C, so this center of circle now becoming center of curvature now. So now just forget about the circle part now. Now just consider AB and this center of curvature C. AB center of curvature C, AB and center of curvature C. So we are finding that at the point of incidence, if you draw a line which passes through center of curvature, incident ray is there, point of incidence, if you draw a line which passes through center of curvature, this incident ray is there, draw a line which passes through center of curvature, draw a line which is passing through center of curvature. So in all these cases, these are different points of incidence, different location of the concave mirror, but one thing is common, कि at these points if you draw a line passing through C, starting from point of incidence, if you draw a line connecting center of curvature, then that line will behave like a normal. So this can be applied to any point on the mirror. Wherever ray is striking from that point, let us say the incident ray is striking here. Now no need to draw tangent. Already whatever purpose this tangent had to serve for our understanding, it has served. Now no need to increase our workload. This is the incident ray, it has struck here, and we already know that if at this point you want to draw a normal, all you have to do is connect this point with center of curvature with a line. So draw here this line. So this line now will be perpendicular to the mirror at that point. Same here, ray is striking incident ray is striking here. Here we want normal. So what we should do? Incident ray is there, point of incidence is there, and center of curvature C is there, and this mirror AB is there. Simply at the point, no need to draw tangent now. From this, join this point of incidence, let's say O with C. This is the normal. In this way now, we know that line segment connects two points. Here we wanted to know the orientation of the normal. So we have located these 2 points O and C. One common point is center of curvature. Wherever the point of incidence might be, from there you join a line connecting with C, there voila, you get your normal. In this way we have simplified. Now you don't even need a scale. Point of incidence, center of curvature, join the line connecting them, that becomes your normal. Now let's check it out separately. So here we have made use of tangent radius theorem, and we will check it out for the mirrors now. How the normals, can we find something regarding the normals there? So for concave mirror, this is P, center of curvature, principal axis. Now randomly we have selected few points here where the incident rays are going to strike. So not even drawing the incident ray, this incident ray has struck here. Whatever direction, like this, whatever direction, but here the incident ray has struck. Here the incident ray has struck. At these 4 points, the incident ray has struck the mirror in whatever direction, this direction, whatever. Normal doesn't take into consideration in which direction the incident ray is coming. Normal means perpendicular at the point of incidence. Normal is independent of incident ray. It is not concerned with reflected ray. It's only is that it should be perpendicular at the point of incidence. So these are the 4 points of incidence here. and we have taken concave mirror. So now tell me how to draw normals at this point without even using scale. You have this center of curvature. So we have already seen we should just join the point of incidence with center of curvature. So here we have, this is normal at point of incidence 1. Now as I was telling you, at this point the incident ray might be coming like this, it might be coming like this, it might be coming like this. In whatever way the incident ray is coming, the important thing is the incident ray has struck it there. There we have drawn the normal. So normal doesn't take into consideration how the incident ray has struck the mirror. The only thing is that it is perpendicular to the mirror at that point. Here again, the rays might strike, incident rays might strike in any which way. You want to draw a normal at that point. What you will do? Join this point of incidence with center of curvature. You get the normal. Here again, let's say this point here. Ray might be striking any which way. Just draw. This is a normal here. This is a normal here. So we find that there were 4 incident rays were there in whichever way they were coming, and we have drawn 4 normals. The 4 normals are 1C, 2C, 3C and 4C. Line connecting 1C, 2C, 3C, 4C. And all these 4 normals, as you can see, are meeting at one point, center of curvature. You can extend them, but one thing we can say for the concave mirror is that normal drawn from any point on the concave mirror will always pass through center of curvature. Conversely, we can say that any line starting from point of incidence passing through center of curvature will behave like a normal, and we can say that the normals for concave mirror converge at center of curvature. Let us check it out for convex mirror. How we can apply this for convex mirror? Same tangent radius theorem we are going to use. This is convex mirror and its center of curvature lies here, C. This is point 1, 2, 3 and 4. So here the rays might strike, incident rays might